Okay, like I was saying, we will express this mathematically. Okay, we will have that E, the sign of proportionality, yes, is directly proportional to F, which is the force. And now we have E is equals to KF. When you remove this sign of proportionality, we have what we call the constant. Now when you remove this sign of proportionality, we have the equality signs coming. And this sign of proportionality changes to K, which we know as the constant. The constant in the Hooke's law. So we say that where E is equals to or is measured in meter, the unit of their SI unit is in meter, and F is the SI unit of force here, F is in Newton. So we will have K, the constant, to be equals to, when we divide both sides, we want to make K subject of formula now. Okay, let me show you how we do that. Making K subject of formula. Which you have done changing of formula in mathematics. We'll just bring a brief of it here. We say divide both sides by the coefficient of K. And what is the coefficient of F there? The coefficient of K is F. So the coefficient of a number of a value is the letter or number that is added or multiplied to that value. Then we have E divided by F is equal to K all over the K times F divided by F. So that F cancel F, we now have K to be equals to E all over F. Now mind you, we are looking for the SI unit. The SI unit of K. And now we say if E is measured in meter and N is measured in Newton, from the rule of standard form, we will know that this, when we remove this sign, it means in division it means minus. It means minus from the rule of standard form of numbers. When we remove this division sign, it means minus. And then we have only one letter of N here. So we will have that K will be equals to, when this sign changes, this is now N minus 1. Mn minus 1. Just like if you say 0 minus 1, we have 0 here from number line 1 minus 1 minus 2, 0 minus 1, 0 minus 1 is minus 1. So here is 0, here is 1. So 0 minus 1 will give us minus 1. So we now have that this is N, K is equals to N meter, K is equals to meter per Newton, or meter Newton minus 1. So these are, is either you use this as the SI unit of the constant. So we move back. So now we can now have E to be equals to meter, F to be equals to Newton, and K to be equals to meter per Newton, or meter Newton minus 1. Now this is all the variables that are involved in the calculation of Newton. If you have this equation at your hand, this equation, this is the relationship between the constant, the force, and the extension. K is equals to E all over F. This is the relationship. The relationship between Kf and E is denoted by K is equals to E all over F. Having established that, we'll move to what we call